Bitcoin and other applications of blockchain. Chunk4, Professor Massimiliano Sala, University of Trento. Bitcoin transactions. In this chunk, we will give a presentation of Bitcoin transactions, what they are, why we need them, how we can create them. We will start with an example. Let us suppose that Bob buys a coffee at Alice's cafe and he wants to pay using Bitcoins. How can Bob pay Alice? First of all, it is necessary for both Alice and Bob to possess their own Bitcoin wallet. Alice tells Bob the Bitcoin address of her wallet and the bill. At this point, Bob creates a Bitcoin transaction of the due amount from his wallet to Alice's. In our example, Bob is the sender and Alice is the recipient of the transaction. So we have a sender and a recipient. But what is a Bitcoin transaction? Bitcoin transactions are the means by which each user can transfer a certain amount of his Bitcoins to one or more users. And also, with a transaction, a user can prove to be the owner of a certain amount of Bitcoins. In more details, each transaction consists of three parts: metadata, and input and output. We are going to examine each of them in detail. The metadata contains information about the transaction itself, such as the creation date, the file size, the identification number, etc. The most important is the transaction identification number. This number is a sequence of digits and letters, and it's the identifier of the transaction. Here you can see an example. This example looks random, but actually it follows a Bitcoin standard, and it is calculated from the input and output of the transaction itself using a hash function. The input consists of the transaction sender, Bob in our case, the transaction identification number of a previous transaction with Bob as a receiver, as a recipient. And finally, the input must contain Bob's digital signature by means of his private key. The output. The output provides the recipient's Bitcoin address, in this case, Alice's, but also the number of Bitcoins that have to be transferred to Alice. In our example, the price of the coffee. If you look at the details of a transaction, well, they are not so easy. But let's look at this. We have said that in input, Bob specifies the ID of a previous transaction, where Bob was the receiver. Why this? This happens because there is no central authority or trusted third party to confirm the authenticity of the transaction. So the only way for Bob to prove to possess Bitcoins is to show that he previously received them. After creating the transaction, BoAB, of course, signs it using the digital signature. We recall that the digital signature certifies the signer's identity and is based on a key pair, the public key and the private key. In our case, the private key of BoAB's Bitcoin wallet is used by BoAB to sign the transaction. The public key of the same wallet is used by any user to verify the authenticity of the signature, namely, has not been forged. It's also possible to have multiple inputs in a transaction. Let us consider an example. Suppose that BoAB wants to pay the amount of 30 bitcoins to Alice, but is not the recipient of any transaction with 30 bitcoins. No problem. BoAB can insert into the input of a new transaction one or more transaction IDs. For example, one when he received 10 bitcoins and another when he received 20 bitcoins. In other words, the sender can insert a list of transactions he previously received in the input of the new transaction in order to reach the amount of bitcoins he needs for the payment. This is the example just described. We can see on the right the current transaction in which BoAB is the sender, Alice the recipient. In input there are two identification numbers of all transactions, both received by BoAB. One is of 20 bitcoin and one is of 10 bitcoins. And using this, BoAB can pay 30 bitcoins to Alice. It's also possible to have multiple outputs. Let us see an example. Suppose that BoAB wants to pay 12 bitcoins to Alice and 18 bitcoins to Charles. And he wants to pay using transaction of 30 bitcoins he has previously received. BoAB can insert Alice's Bitcoin wallet into the output of the new transaction, to which he sends 12 bitcoins, but he will also insert Charles' wallet, to which he sends 18 bitcoins. So, in the output of a transaction, any sender can insert a list of Bitcoin addresses for the payment recipients. This is a description of the example just described. We can see that in the current transaction on the right, BoAB is the sender, there's BoAB's signature, Alice and Charles are the recipients. You can see the wallet addresses of Alice and Charles. And we can see that 12 bitcoins are going to Alice, and we can see that 18 bitcoins are going to Charles. But in input, there is only one transaction on the left, when BoAB received 30 bitcoins from Diana. Note that the sum of bitcoins in output is the same of those indicated in input. But what happens if you don't want to spend all bitcoins? We are going to find out in the last example of the chunk. So what about change? Suppose BoAB wants to pay the amount of 25 bitcoins to Alice using a transaction previously received by him with the amount of 30 bitcoins. What can BoAB do? Well, BoAB can insert into the output two things. Alice's address, to which he sends 25 bitcoins, and his own address, to which he sends to himself 5 bitcoins. This represents the change. So BoAB is free to send his bitcoins to anyone, including himself, but it's necessary that the sum of bitcoins indicated in the transaction input is at least equal to the amount of bitcoins in output. This is a description of the example that we gave. Now, if you look at the current transaction on the right, you will see that BoAB is the sender, because there's BoAB's signature. Alice and BoAB himself are the recipients, because we have Alice's address and BoAB address. And we can see that BoAB is sending 25 bitcoins to Alice and 5 bitcoins to himself, which is the change. And in input, you see a reference to the transaction on the left, which shows when BoAB got 30 bitcoins from Diana. We can summarize what we have seen in this chunk. Two people, each having his own wallet, can exchange bitcoins. To send bitcoins, they need to create a transaction. The created transaction must refer to one or more previous transactions whose recipient is the sender of the current transaction.